The Chester F. Carlson Center for Imaging Science at RIT is a unique place where we combine all the multidisciplinary aspects of the imaging chain. From the photons, how we capture those photons onto a detector, exploit that image for information, and perceive the world around us. We also have a heavy emphasis on artificial intelligence, because in exploiting imagery, understanding imagery, developing algorithms from imagery, AI is becoming increasingly important. We offer both master's degrees as well as PhD degrees in imaging science, and we are the only institution in the United States that offer those degrees.
An imaging science graduate degree provides specialized knowledge in image analysis, processing and interpretation, advanced knowledge in optics and photonics, advanced machine learning and computer vision skills. So this really prepares students for their future career, being able to deploy this knowledge directly into their work.
Imaging science can teach us a lot about our world. We try to extract as much as we can from drones, from satellites, for climate purposes, for defense purposes, and it's very integrated in all the industries that we do right now.
I feel the Center for Imaging Science is a place where you learn a lot of things from others while also growing individually. The faculty here at RIT are very approachable and collaborative, and they're very supportive with what research you want to do.
We do cutting-edge research across a wide range of imaging systems and across a wide range of application places. And we do that all with an eye on student success.
One of the things that I really like in imaging science is that graduate students have access to all this world-class instrumentation and labs. You will get hands-on, practical experience with these imaging systems.
We're asking very hard questions, and that means we need cutting-edge tools. We have state-of-the-art imaging systems that fly on drones or that are used in laboratory settings, various optical setups to study all kinds of different detectors and optical fabrication of materials. We also have advanced computing resources here, both individual sort of edge computing systems as well as very large research clusters.
Some students focus more their research on medical imaging, some on remote sensing, some more on human vision or computational imaging. So it's all based on students' interest on how they want to continue their career.
My research pertains to modeling the reflectance of light off of a very specular or mirror-like surface that has some level of roughness that I've induced. It kind of lies between two ways of defining how light is interacting with an object. I'm so passionate about this line of work because I see how applicable it is to things that I personally care about. I'm personally very interested in one day going to space domain awareness, and a lot of different optics and a lot of different imaging is going to be extremely important.
So my research focuses on integrating multiple camera information together. I specifically focus on hyperspectral cameras. They're special cameras whose strength is material characterization. You can look at a certain object and you can tell not only what its color is, but what it's made of.
I'm working in the Perform lab, and my work revolves around stereo vision, which relates to our ability to see things in depth. And our main question is, how much does it contribute to our visually guided action, like when we interact with nature or even doing simple tasks like catching a ball or placing any object or even walking?
We also place a strong emphasis on co-op internship opportunities. It's often as easy as one of the professors picking up the phone and calling a national lab, a company, and you'd have a place for the coming summer to go do your co-op or your internship.
I am in an internship currently, and I'm working with a lot of other RIT Imaging Science graduates. It does feel pretty nice seeing immediately how much what I've been learning actually applies to what I'll be doing.
Once you graduate from the center, you can go work in any kind of environment where cameras or sensing plays a paramount role. And as you know, cameras have become ubiquitous.
Our graduate students are in very high demand. Several of our students have been at places like Los Alamos, Lawrence Livermore National Labs, Air Force Research Labs. We also place a lot of people in the aerospace industry, places like Lockheed Martin, L3 Harris, Boeing, all of their corporate R&D labs, as well as in the consumer electronics industry. So a lot of our students go off to work for people like Apple and Google in developing new display technologies, new camera technologies, even new technologies for things like autonomous vehicles and advanced precision agriculture.
You should come to RIT Center for Imaging Science because it offers a unique blend and integration of advanced research, state-of-the-art facilities, and real-world imaging application, all within collaborative and supportive environment that prepares students to become leaders in imaging, optics, and AI.
I think imaging science is a good fit for that student who wants to move beyond the theoretical into more of an applied type research environment.
If you are interested in an interdisciplinary sort of approach to solving real-world problems, then the Center for Imaging Science is a great place to do that.